Hello, in this example we're going to find the interval and radius of convergence of the sum n equals 1 to infinity of 2x minus 1 to the n over 5 to the n root n. Okay, so to find the interval and radius of convergence, if it's not a geometric series, you want to use ratio test. Okay, this is not a geometric series. If we didn't have that root n, it would be a geometric series, and we could just use the fact that it's a geometric series. But with the root n, we need to use ratio test. Okay, so we're going to take the limit as n goes to infinity of absolute value, the n plus first term, 2x minus 1, to the n plus 1 over 5 to the n plus 1 root n plus 1 divided by 2x minus 1 to the n divided by 5 to the n root n. Okay, so we can't drop the absolute value bars in this case because we don't know if x is going to be positive or negative, or this 2x minus 1 is going to be positive or negative. But what we can do is we can multiply through by the reciprocal of the denominator. This is the limit n goes to infinity, absolute value. So that's 2x minus 1 to the n plus 1 divided by 5 to the n plus 1 root n plus 1 times 5 to the n root n divided by 2x minus 1 to the n. Okay, so we can simplify this a little bit. We can cancel out a 2x minus 1 to the n, and we can cancel out a 5 to the n. Okay, so 5 is always going to be positive, but notice that the 2x minus 1 that we have left over and the 5 don't depend on n anymore, so we can actually pull those out in front. Okay, so we end up with absolute value 2x minus 1 over 5 times the limit as n goes to infinity of root n over root n plus 1. This, you can factor out a root n from the denominator, and then cancel with that, and this limit should go to 1. So this limit is going to be absolute value 2x minus 1 all over 5. And since we used the ratio test, this is going to converge when this is less than 1. Okay, so that means we can get to here. We can multiply both sides by 5, so absolute value 2x minus 1 should be less than 5. Less than 5. And what we really want to do here is we can divide everything by 2. So we get absolute value x minus 1/2 is less than 5/2. Okay, and this 5/2 is going to be our radius of convergence. Okay, so we need to find the radius of convergence. There it is. Okay, how do I know that this is the radius of convergence? This coefficient here has to be 1. Okay, so to find the interval of convergence, we can now get rid of the absolute value bars. So we go from negative 5/2 is less than x minus 1/2 is less than 5/2. Add a half to everything, so this should be negative 4/2 is negative 2 is less than x is less than 3. Okay, and since we used ratio test, we need to check the endpoints. Okay, so if we check the endpoints, we can check x equals -2. So we'll replace the x here with -2. So when we do this, we get this series, sum n equals 1 to infinity. This should be -5 to the n over 5 to the n root n. This is going to simplify to be n equals 1 to infinity of -1 to the n over root n. And you can quickly check that this should converge by the alternating series test. We need to plug in the other endpoint. The other endpoint is x equals 3. At x equals 3, the series becomes sum n equals 1 to infinity of 5 to the n over 5 to the n root n, which is just n equals 1 to infinity of 1 over root n. And this should diverge. This diverges. It's a p series with p equals a half. Okay, so so now that we know precisely when this converges and when it diverges, we know it converges at x equals -2, so we add an equality here. We know it diverges at x equals 3, so we don't. So you can write your answer like this. Or you can use interval notation, which would look like converges on the interval, including -2, but not 3. Thank you.